So far we have only looked at linear problems, so 1 and 2 dimensional, but there's a lot of examples that involve circular motion. So that's why we are going to study circular motion. The speed of an object that is moving with circular motion is given by the following formula. So you have to write this in. V is equal to 2 pi r divided by t. Where r is the radius of the curvature, which we measure in meters. So if you're given it in centimeters or kilometers, make sure you convert it to meters. And t is the period, so that's like our time, measured in seconds.
Is this on the formula sheet?
Yes, I think so. Let's take a look at our... Yeah, let's pull out our formula sheets. That's a good point. And this one, yeah, as Rael pointed out, this is under the kinematics part of your formula sheet. So under kinematics unit, your formula sheet there. Good question. Okay, so this is the formula we'll use for measuring the speed of an object with circular or uniform circular motion. The period of an object moving in circular motion is related to frequency. So frequency is the number of revolutions in 1 second, whereas period is the time it takes to make 1 revolution. So if you're given frequency, but you need to use this formula, you need to convert it into t by going t is equal to 1 over f. And your f is hertz or seconds to the power of -1 or 1 over seconds. So this is like 1 over s. Same thing. All same units. So if a question gave you the frequency but you needed the time or the period, you need to do that conversion. So it's important to know the difference between frequency and period. Between f and t. I guess f is lowercase. So it's important to know the difference between the f and the t. So that would be something that you should memorize, those definitions, so that you have them clearly. So, if we think about something moving in circular motion, so for a mass in circular motion, the speed of the mass is uniform or constant, but the velocity is not. So let's assume that, say, I'm spinning this at a constant speed, that just the way that my hand is moving is going constant. So this is staying the same speed, but velocity references direction. Is this going in the same direction? No. It's changing direction constantly, right? So it's moving. If I was to plot this direction, it's going like this way, and then it's going this way, and then it's going this way, then it's going this way, okay? It's always moving. So our actual velocity is always moving, even though the speed stays the same. Or maybe I should say our velocity is always changing, because velocity refers to magnitude and direction. So if our direction is changing, velocity changes. That means if our velocity changes, we must have acceleration. Because the definition of acceleration is change in velocity. So that must mean that when things are moving in circular motion, they must have acceleration. So, and that's what I say here. When an object is moving in a circle, its direction is always changing. Therefore, its velocity is always changing because velocity is a vector quantity. Since the velocity of the object is changing, it then must be accelerating. This is called centripetal acceleration, and it is calculated using the following equations. So some of you might have already jotted this in, but I want you to write down AC is equal to V squared over R, or if you don't have velocity but you have both radius and your period, it's 4 pi squared times R divided by T squared. So, yeah, either one. So it's like AC is equal to V squared over R, or AC is equal to 4 pi squared R over T squared. Both give you AC. So it depends on what your question gives you, what you need. This is also on your formula sheet under kinematics. So look and find it under kinematics there. On formula sheet. Okay, so where AC means centripetal acceleration, so the acceleration due to uniform circular motion. R is radius in meters. V is the tangent, due to the tangent, instantaneous velocity. I'm going to show you that in just 1 second. Okay? And T is period in seconds. So make sure that it's all meters in seconds or meters per second and meters per second squared. So centripetal means center seeking. So centripetal acceleration is always directed to the center of the circle. So my velocity is always changing, but our acceleration is always pointing to the center of the circle. That's what centripetal means, okay? But we know that something different happens sometimes, or well, not sometimes, all the time. Where did I put it? Oh yeah. So, if I am to spin this ball, okay, so pretend I'm exactly in one spot. So, I'm getting busy. If the ball, what kind of motion does it have right now? Centripetal or whatever, okay? So, if I let it go, oh, okay. Why did it go that way and not keep spinning in a circle? Talk about it at your tables for a minute. Why didn't it keep going in a circle? Why does it move in a straight line when it's let go?